Hello everyone, welcome back to your Take 5 5-week study plan. Today we will continue with the command of evidence question in the SAT reading. To recap, we discussed the first type of evidence, the textual evidence in lesson 12, where you are asked to find evidence in the form of an example, a specific explanation, or a quote to support or undermine a conclusion or a hypothesis stated in the passage. Lesson 13 is the second part of this question, where you will dive into another type of evidence, the quantitative one. The goal of today's lesson is to familiarize yourself with how data is presented in the SAT reading and the most efficient way to interpret it to provide logical evidence for a conclusion. This is a very practical type of question that you will encounter later on in your higher education or in general how to develop your critical thinking when it comes to empirical evidence. In fact, many authors and researchers, including yourself in the future, will encounter this task of finding the right piece of data for the argument. You will notice similar wording in the question in blue here, in which they ask you to find some information from a table or a graph to support or undermine a claim. Essentially, the approach should be similar to what we have learned in lesson 12. It is important to know what claim or argument is about before finding any evidence to support it, because there will be a lot of information in the data or graph presented that might either be irrelevant to the claim or directly undermines it, which is the opposite of what we need here. In other words, it is better to not focus on interpreting the data presented fully without knowing what we are looking for. Now let's take a closer look at this example. We first need to know what the student's claim is. By this time, you should be comfortable quickly scanning to spot the location of this claim without being too caught up with other details. We can see it in the last sentence. In some regions, honeybee populations had not only rebounded by 2020, but also reached their highest level in 60 years. The sentence tells us that there are two conditions that must be met. In 2021, they had rebounded. This means they increased after a decline. And two, they had reached their highest level since 1960, or you can do a quick math of 60 years from 2020 here. For an answer to be correct, both of these must be true. Once we have a good grasp of the claim and what we should look for, we can proceed to the data provided. Now let's take a look at the graph to find something that illustrates this description. We are presented with a line graph of 4 continents showing the colonies trend line from 1960 to 2020. Take some time to first familiarize yourself with the legends, or how each variable, in this case the continent, is graphically presented. Usually for line graph, legends are shown in different types of line, like dash, dot, etc. Each type represents a variable to distinguish visually. Line graph is not the only graph you will see in the SAT. In fact, you will see many other different types, and line graph is just one of the more popular and easy to interpret types. Don't concern yourself too much with having the savvy to quickly grasp all types of graphs, because it's not necessary. With enough practice by doing the quiz and the homework in this study plan, as well as coupling with the domain practice and the mock exams in the Take5 study plan, you will get the hang of some familiar graphs like line graph, bar chart, table, etc., as well as some more quirky types. More important than understanding how the data is presented is knowing what we are looking for. Here, we need to find a region or a continent that supports the student's claim that in 2020 it experiences a rebound, meaning it increases after a drop. And two, it reaches its maximum since 1960 or in 60 years. You can approach this in different ways, but make sure these two conditions are met. Here it is easier to first spot which region experiences the peak in 2020. We can eliminate Americas since its peak is around 1990. For the other criterion, we are looking for an increase right before 2020 point, but there has to be a decrease before this increase. So for Asia, it is a constant increase since the 1960s. Africa, it's also a gradual increase in the 60-year period with no clear sign of fluctuation to fit the rebound description. Only Europe demonstrates this. From 2000 to 2010, the line shows a decrease and then recovers from 2010 to 2020. So Europe has to be the right answer. Let's take a look at this non-science example. As usual, we first need to know what Chang and Quantitative finding is. It is stated at the end of the paragraph that most readers prefer print books to ebooks. Even though the statement is written in a more involved way, you are expected to derive the essence by paraphrasing it, using the skill you learned in Lesson 9, Central Details. Now move on to the graph. This is a stacked column graph, a more specific type of column graph. You will see the column or bar graph type a lot because it's a very efficient way to compare between groups. There are many variations for the column and bar graph to serve more specific purposes, and the stacked column here is a very useful way to visualize the components that make up the full 100% of each category shown in the y-axis. The column represents all situations of book readings, and the two legends in dark and light shades probably represent the percentage of readers' preference for print or ebooks in that genre. Since we are looking for evidence to support most readers prefer print books to ebooks, we need to find in the graph how this information is reflected. In our guess, it should be in a specific situation that shows the column ratio mostly in darker shade, reflecting the majority of readers of the genre who prefer print books. Here, two genres fit that description, read to child and share books. The range of titles seems appealing, but it is too close to 50-50, so it's too much of a stretch to claim that most readers prefer one type to another. Now we need to find the right answer for this observation, since the answers of these questions are not as straightforward as the previous, which is C. A portrays the right information that the column quick assess, but it is a wrong paraphrase of the researcher's finding to illustrate how easily accessible ebooks are relative to print books. But this is the subordinate dependent clause, not the main claim stated by the researchers that most readers still prefer print books over ebooks, even though it is not as easily accessible. So, even though it is the correct interpretation for the data, it is irrelevant to the claim. This is a classic trick of this type of question. Similarly, B also portrays the right information presented in column range of titles that readers don't mind the format when it comes to the variety of titles available, or in other words, both formats offer a comparatively rich range of titles for readers. However, it is not the finding researchers want to present. It is a finding from the data, but not supporting the researchers. Still a classic trick. They provide you irrelevant data to the claim. For D, the answer presents complete wrong interpretation of the graph. People do not prefer the same format for quick access and reading during travel, but indeed, most readers prefer electronics to print. But even if it does interpret the information correctly, it is still directly against the researcher's finding. It actually undermines the claim, showing readers' favor to ebooks to print books instead of the opposite. So in short, tricky answers give you either 1. Wrong interpretation of data, 2. Right interpretation of data but irrelevant or even undermines the claim. This is why if you start with checking whether the answers interpret the data correctly first, which is tempting because the graph is usually easier to interpret. That's the whole point of visualizing data. It helps communicate points more effectively. It's quite a waste of time because you can only eliminate D here. Graph and data can also be presented in a somewhat harder way to interpret in a quick glance, like the last two examples. One particular type of data presentation that usually takes more time to analyze is a table. Let's say we ignore the paragraph and jump to the data first. The table is very easy to understand. It represents two metrics of effectiveness of different antibiotics. However, it is hard to get the insight from just this presentation. Unlike line graphs that show trend line or stacked column graphs to show the components of a whole, it's harder to analyze the tabular data without any hypothesis to prove. This is why it's always a good practice to just read the graph to know what claim we are working with first. Even though the question asks us like an inference question to complete the text, it is not a conclusion that we need to infer from, but an example to illustrate a point. So what is the point? We need to read backwards a few lines, and there it is. An antibiotic, the subject we probably need to find since it's not defined, has a high level of general effectiveness, but significantly low in MRSA effectiveness. So we want to find a row that represents the antibiotics that have a good numerical percentage on the second column, but a much lower value on the third column. Well, to help us interpret easier, let's just call these antibiotics by their initials. This discrepancy is shown in all lines except for type V, since it's 100% effective on both metrics. But we want some antibiotics that are effective generally, so it's safe to say type E and type P are not. We are down to just type M, C, and R. Well, it might not be a good idea to try to spend time calculating the actual difference between the two metrics and choose whichever has the highest difference. After all, this is not a math question. Let's move on to the answers and see how we can find the most appropriate answer that supports this claim and represents the data correctly, according to our rough analysis of the table. As stated, we do not need to look at eliminated rows anymore, so we don't need to look into statements about type E, which is in A, and type V, which is in C. Type B is comparing the difference between general effectiveness and MRSA effectiveness of type M and type C, which we can check if the number is correct. But again, even if it is right, it is irrelevant to the claim. We just want to show some antibiotics that illustrate the description of lower MRSA effectiveness to general effectiveness. No need to compare which antibiotics have the biggest difference. D, in fact, does the job. It just reports the two metrics of type R without the need to calculate the discrepancy, so you do not need to check if it's correct or not. It does the right job that reflects the right data in the table. An example for the scientist's claim. See, sometimes it is not always the best idea to fixate on quantitative analysis, even though you can do many things with the presented data, but not always necessary in the SAT. Let's put everything we learned together in solving these 5 examples here. Feel free to pause the video and try to solve it on your own first. For this first example, it's a bit twisted because the question asks to find evidence that undermines the conclusion. Let's look for the student's conclusion first. Right at the end of the passage, we see that the student concluded that brown bat species were not affected by the disease because the species has the highest number of cries. So, the student wants to establish a negative correlation between bat cries and being affected by the disease. So, to undermine this conclusion, we want to find the case where brown bat has low number of cries. In the graph, we look for brown bat, which are displayed as 2 names here at the end, big brown bat and little brown bat. The big brown bat has 10 bat cries on the bar. And the bar also shows the highest number amongst all species. But little brown bat has on average almost 3 cries only. Not the lowest, but definitely not as high as other bat species, which disagrees or undermines the student's conclusion directly. So we choose answer B, which reflects this information that we just found. The second example is slightly more advanced, not because of how data is presented, but rather how to derive the right claim at the first step and eliminating tricky answers later. Again, with the text completion question style check to ensure that this last sentence is an example, not a conclusion like an inference one. In the previous sentence, the passage states that although El Nino does not result in consistently heavy rains throughout the year, the difference in rainfall during the winter in El Nino years can be much greater than the difference during other seasons, and Los Angeles is then cited as an example of a city where this is the case. This example should tell us that in the summer or non-winter months, LA has the same average rainfall on average in May and during El Nino rainfall, which is 15. But in the winter, these 2 variables are more significantly different, so much greater than 15. As you can see, to be able to derive this example from the general conclusion is not an easy skill. It's actually the command of textual evidence skill we just learned in lesson 12. That is why, if you have followed the Take5 study plan ordinarily up to this point, you should be able to progressively improve your SAT reading skills and find it much easier to combine previous skills into solving more advanced questions like this. Okay, now we can spend some time to check the chart out because it seems to be a little bit more complicated than the previous bar graph. This is a 2-column graph with 2 legends representing average and El Nino average rainfall. The y-axis describes the quantity of average monthly rainfall, and the x-axis represents 12 months from this July to next June. Overall, we see a simple pattern that all light shade columns are higher than dark shades columns in the same month. In other words, El Nino rainfall is more than average rainfall every month. We match the information in the last example, saying that in May, both average and El Nino average rainfall are around 15 millimeter, which is illustrated by these short and fairly similar in height columns here in May. That is good enough. Don't get trapped in diving deeper into the analysis rabbit hole. Now we know what we are looking for. Something to show that the difference between average rain and El Nino rain are higher than 15 millimeter in winter months. Let's go through the answers and eliminate. A does not present a month where El Nino rainfall is higher than average, which is October. The difference of the 2 columns on the graph looks good, significantly bigger than the difference in May, so quantitatively speaking, it is also larger than 15. However, this difference is incorrectly reported in the answer, as 5 mm is much smaller than 15 and does not reflect the right data, nor the large difference description that we are looking for. B does not include the comparison between the two legends, average and El Nino rainfall, so this answer can be eliminated. C does not fit either because the correct answer must involve months in which El Nino rainfall is higher, not lower, and therefore there is no information about the size of the difference. We are left with D, which cites an example of a winter month, February. Checking for this month data presented in the graph, this is a correct winter month in which El Nino rainfall is much higher than the average. We can also see that the average column shows a value around 75 and the El Nino column is around 160. So the difference is roughly 100 millimeters, just like the answer. So you can see that these answers are quite tricky because they mention something partially correct, either supporting the claim or reflecting correct data. But the only right answer will have to give an example that both support the claim and use the accurate data. With quirky graphs like this one, don't be intimidated by its seeming complexity. This question is actually much easier than it looks. Follow the steps we have done so far. First, what is the researcher's conclusion? You will find it in the last sentence. The accelerated growth of the plants was caused by the increased supply of red light provided by the WCM films. Now, let's roughly interpret this graph together. It's always a good practice to read the title of the axis as well as the unit of measurement. We see that y-axis shows intensity and x-axis indicates wavelength with notation to separate ultraviolet for smaller wavelength or on the left side and the red for larger wavelength or on the right side. Since the graph does not mention anything about growth of plants, the only way the data can support the researcher's conclusion is to bridge the gap of WCM film and red light supply. So, we are looking for an answer that supports the idea that the films increase the red light supply. Notice that only answer C mentions the films, so let's examine it first. Indeed, the graph does confirm that with wavelength more than 600 nanometers, there's a spike in light intensity because of the film. So it is a correct answer because it supports the researcher's conclusion while effectively use the accurate information of the graph. The other answers include information about light wavelength, intensity, and absorption, but do not explicitly mention the effect of the films. Let's try another table example. What is the researcher's observation here? It's located at the last sentence, telling us that the lack of standardization could contribute to inconsistencies in the findings of similar studies. What does lack of standardization mean? If you read backwards a couple sentences or even the entire passage, you can see that these similar studies employ a variety of methodologies, criteria, and type of participants. This means that these studies are very different from one another. This is the meaning of lack of standardization. They are not standardized or they are not uniform. A glance at the table tells us about 9 different studies with description of their participants. So the table can tell you more about how each of these studies varies from one another. Hence, the correct answer must therefore mention a factor that varies from study to study and include a comparison of some type. So let's eliminate answers altogether now. B does not mention a different factor among studies, and it is even an off-topic one. This is a wild guess for students who have an assumption that just because the main topic of this passage is studies involving video games, all of the studies should have children as participants. Answer C and D mention factors that remain the same across studies, which go against the conclusion, so both choices can be eliminated. Only A mentions an inconsistency that illustrates the researcher's observation. Two studies differed noticeably from the other studies in size and age demography of participants. You can verify this with the table data, as it is true that other studies, except for Takeushi's 2016 studies, have smaller sample size and varied age group from adolescent to older adults. This is exactly the lack of standardization amongst all studies mentioned in the conclusion. Sometimes with simple enough graph like this last example and sharp enough data analysis skill, you can go straight from graph analysis to answer selection without reading through all the answers. Of course, you still have to start with understanding the main claim to support first. We can find the researcher's finding in the last two sentences. Let's paraphrase this finding to better interpret it. Technically, it means that the higher the noise, the lower the fundamental frequency produced. They specifically highlight in the last sentence for some cases, or for some cells. They produce much lower frequency in high noise than in low noise. The column graph tells us the comparison of frequency for each cell in three situations: no noise, low noise, and high noise. So the answer should be about a specific cell that has a significantly higher low noise or light shade column than the high noise or crossed column. Visually, you can see that this is the exact description for cell A, as the gap between these two columns is the largest compared to other cells. You can also do some rough calculation of this gap. So between 400 and 300, the difference is around 100. We can now proceed to check for answers that mention cell A, which are B and C. B describes the right number of difference between high and low noise, so this must be the correct answer. C is incorrect, because even though it mentions the right difference of 125 between high noise and no noise, it's not the right comparison we're looking for. Moreover, it also mentions cell A only to highlight the overall lower response of cell B, which is not the right subject that we want to use to demonstrate the findings. So that's the end of today's lesson. It is an overall quite challenging one if you're not familiar with data analysis as a skill. Make sure to practice and read the explanation provided in the quiz section, as well as score how well you master the skill in homework. You can also find more practice with the right level of difficulty for this skill in the domain practice section, filtering for command of quantitative evidence skill.